All right, so we're starting to get our board wired up. These two are in pairs, so we've kind of bound them in pairs. This one wire connects to both relays and triggers in both at the same time, so we've created like kind of a jumper with two of those there. And what I did is I just took a bunch of these, the male to female jumpers, and I've just cut them and trimmed them to size. That way I don't have to bother with crimping the ends on myself. Now we also have a scenario where we have we have the V in and we have the ground, and we have a lot of these things that have to be on the same power and ground, including the receiver. So what I'm doing is I'm creating like a little bus. Well, here's an unfortunate thing. Both of these three terminals here seem to be stripped before I even got to them, like before I even did anything. They just spin, they won't go up and down. And so that's one danger of having hot glued the board already. So, we have a little bit of violence with the wire cutters. We were able to pop everything out and leave just tiny little pins sticking up with a whippo. Broke off my saw. Now I can just hack those up and pluck them out and be able to solder down from the top. And of course, this wire gauge is just a little bit too thick for those holes, so I've flattened. Focus. So I flattened that out, and I will take the wire cutters and trim up from the bottom to get it the right, like maybe half or something, and then re-round it with the needle mows, and then heat it and stuff it. Playwright said that was a little stupid, but it came out cleaner than it did with the terminal blocks anyway, so it'll be okay. And I had glued these down, and I asked for reversed, so one is a female and one is a male. That way the motor can only plug in, and they'll each come in from one side. I'm trying to make this as easy as possible, like in rewiring, so you can intuitively tell where everything goes. So this is actually a reshoot. The first time through, I had a bad component, and I was trying something that I wasn't sure was going to work, and it didn't. And I'm going to tell you about that too. All right, so we start off with our quick disconnect. Comes up to our power switch, and we have an indicator light. All right, so our positive is switched. Our ground goes straight in. One of the things I kind of wish I had done, and I might still do, is instead of having this ground, right into the lug, I just don't feel like that gives a great connection. I think what I'm going to do is I'm going to take this and I'm going to run it right down into the solder cup, and just have it follow the ground up in. That way, nothing can really, it's less likely to come loose up here. So this is our saber tooth, and these are our two motors, and these are our power lines in. We have 3 voltage systems going on in here. All right, we have 24 volts going to our saber tooth, and that's what gets switched. We have a 12 volt buck converter here, where our input goes to that, and then it outputs 12 volts to our L298N driver board. This driver, it controls 2 motors here and here, and that goes for our actuator and our chute rotation. So this puts out about between 1.5 and 2 amps, somewhere in that range, maybe slightly more. It has a nice thing there that'll tell you how much voltage it's putting out. It's adjustable voltage through the pot. And it'll tell you the battery voltage, and it'll tell you how much voltage it's kicking out, which is kind of a nice feature. It doesn't have as much power on the actuator as it's capable of. Before this if I put it all the way down, I could actually jack the tracks right up off the ground. It's not capable of supplying that much ampage. It's actually in tune with this small driver board. Like, those two are fairly well matched right now. I might bump that up eventually along with that. We'll see. I don't really need it to be able to jack up off the ground. There is our 12 volt system, 24 volt system. Sabertooth can output clean 5 volt regulated signal, and that's going to control our Arduino Uno and our relay board. So we have the power and ground going into a power and ground bus. I figured I'd include that because I have multiple things that I have to power off of it. All right, so here is our receiver. So 2 channels of this, channel 1 and 2, they're just wired directly into the Sabertooth, and that handles for the tracks and reading the signal. For the chute and the actuator, the signal, those 2 channels go directly into the Uno, and reads which position the stick is and which motor, and it will translate it and drive that driver board back there for the chute and the actuator. And we also have a relay board, 2 relays, and they both get triggered at the same time by the Uno, and that's a safety feature. So the these gasoline motors have basically a kill switch, and when this comes out, 2 contacts touch, and the motor will shut off, grounds out. So we're going to jump a couple of wires off the back, and we're going to put it into our relay here so that the engine cannot run if the Arduino is constantly reading a signal from this. And if this is not receiving any kind of signal from the transmitter's off, or we're out of range or something to that effect, then this relay is going to kill the engine off. It'll ground it out. Now, the other relay is for one of the components that we've taken out of this system that I will put back in, probably. So we had a bad component. So this is a solid state relay. I should have lived to use a little bit closer. It turns out that these FSR relays have a lot of junk parts from the manufacturer that I got from. So right now this is completely shorted in the closed state. It's supposed to be always open unless it has power back there. So I wanted to use that because it would have less switching noise. No magnetic field, contacts can't get stuck. So this is driven off of this relay right here, which is, this is a 12-volt wire that comes in. It's fused on its own. So that's a normally open contact. So that relay has to be closed in order for this to have power, in order to power the saber tooth. Okay. And that's what that push button is going to be for. The push button is going to jump these 2 leads and let it get power, let the whole system start up. For the system to stay running, that relay will have to be energized. That relay only gets energized if the Arduino reads an RC signal coming in through the receiver. So in order to start this up, what I'm going to have to do is I'm going to have to turn on my RC receiver, and then I'm going to have to push the jump start button, basically. And then once that happens, once the saber tooth is running, then it's going to be supplying the 5 volts to all of this back here. All right, what else? Oh, so my mistake. So here, this was a pretty good one. Initially, to get the 12 volts, I did something a little cute. I didn't know if I could get away with it, but I thought I'd try it. Seemed like it'd work. So originally I was switching the ground, and I had my 24-volt power coming in from my 2 batteries in series. And I also took a 12-volt lead from the battery over there and brought it directly into the case. I'm like, well, I'll have just the full 12-volt battery power without the converter. And because I'm switching the ground, then they'll both go off at the same time. So the problem is I was still at just being at half the potential of the 12 to 24. It's still like a negative voltage. And even though, so I was feeding my 12 volts into here. That was the only place it really touched the system. And even with a diode in there, I was still getting kind of like a negative voltage flowing back through the system somehow. And it was like flowing in through these pins, like the control pins. Because when I unplugged those, it stopped, but this light was just kind of staying on in a dim or half light stage, and the only way it could have happened is if it was like coming all the way back through. So I wasn't sure if that'd work, and it didn't. So I'm sparing you kind of the video describing that up front, because try to make it all clear, All right, so we're gonna go to some other video clips that were shot before, but I just wanted this section to be nice and clear for you. Here's a potential little gotcha. So I put washers around these, and it turns out like this whole heat sink and heat sink on the bottom is grounded. So really there's a 24-volt potential between like, here and here, and the screw's grounded. So it seems like I got an arc in here at some point. Like I did hear a little spark at one point. And the pad of this is very close to that washer. So I'm going to be removing those washers I don't know if I got an arc or what I got, but I can see a little bit of black there. I'm glad the driver board still works. I already tested it, but it's a strange little gotcha there. You know, just a little bit more spacing, whatever. Here's what it looked like underneath the washer. Apparently it blew. Maybe I tightened the washer too much, and it kind of, you know, blew through the trace, got up to it. Glad it didn't hurt anything. I'll hit that with some liquid electrical tape just to give it a covering. All right, now we have the actuator and the chute hooked up. We'll give it power. We haven't heard our relay. I'll turn on my controller. Relay comes on. So we will do, we're going to do chute. Let's see, chute left and right. All right, and then we can do actuator up and down. And you can see we have a fair dead zone. There's a delay in the signal, but let's see. Okay. Oh, not enough hands. So we have a pretty good dead zone, and I can increase that dead zone in the code. So even if the motors were spinning in the opposite direction, controller off, relay down. Even if the motors were spinning in the different direction, like when I did stick right, it spun the other way. All they'd have to do is flip the control signal pins on the driver board for it. I don't have to do any more wiring or coding for it. All right, so I'm going to take you just with the real quick rundown of the code. Sorry, I have to record it on my phone like this. I'm not compatible when I record with the screen capture software. So basically, the entire code is just this. It's like one page. It's very simple. I created an RC motor class that handles all the details. You tell it the 2 direction pins for the L298N motor driver board, and then you tell it the pin that is going to be the RC receiver, you know, which one's connected to the RC receiver. This one must be pulse width modulation. And this 0 here is if I wanted to also include speed control, then I would have to include another pulse width modulation port. In this case, it's 0 indicating that we're not going to bother with speed control. So basically 3 pins for each motor. And this handles all the details of receiving the RC signal and controlling the motor on those 2 pins. So we start up our serial port. We set our relay as an output. We make sure our relay is off. Chute.debug and actuator.debug just indicate that it's going to spit out some serial output or not. And then we also set the dead zone for the actuator, the one that goes up and down to 100. We're making that a little bit bigger so that way it doesn't, we don't hit it by accident. So our main loop is basically if it's receiving a signal at all, then we know that the receiver's on. And then we'd call chute that process, which is basically the same as loop. That's where it does its main processing for each of these. So it's kind of nice that these are instanced, and it makes our main loop just very tidy, very small. And then we make sure that our relay's on so that our motor is running and that our relay that powers the Sabertooth is energized. And if it's not receiving a signal, then we just make sure that the chute motor's off, make sure that actuator motor's off, and we turn off our relay, which will turn off both the gasoline engine and the Sabertooth driver. So, I mean, there's a little bit of complexity in the RC motor class, but it's really all squirreled away. Like, you don't really have to worry about it at all. So that's it. That's all that the code does. And all of this is public. This is all open source. Here's a quick little view of the RC motor thing. And, I'll let you guys go through that on your own. It's really only a couple pages, but that's all handled for you. So the main part of the logic, all that you have to worry about is really just in this loop, and it's very small and tidy. So, all right, in order to test the tracks, I want to get them up off the ground. So I've raised the front part all the way up with the actuator. And then I use the front as a lever, push down on that, roll it back with that in reverse. So now I'm on a block that. All right, so we got it jacked up. And we're going to do a forward stick, and we can see our wheels are rolling backwards. So, and they're both doing the same thing. So all they have to do in there is the two motor wires, they just have to flip them on both sides. All right, so we're ready for our little victory lap. Okay. Actuator is a little slow. Kind of want a little bit more speed on the shoot. I mean, it's not bad. I can live with that. I wish, and I want a little bit more dead zone on the actuator. And that buck converter does not really have enough power. I mean, it has enough power to work, but I don't know. It's just not great. And I think I want to do, it's a little bit touchy how I'm turning. That turns a little too fast. I'm going to, I think the controller supports a scaling mode where, you know, it doesn't react as fast. And also when it's moving, you can see the control box is a little bit too floppy. Now it isn't really welded. I'm going to have to use a stiffer piece of wood underneath the control box to take that wobble out. And also pour the, I think the steel bear might need to be just literally welded. Too much shake. But I gotta say, it's not too bad for a first run. And overall, the speed is good. You know, that seems pretty good to me. I don't think I'm going to be snowblowing much faster than that. So, I don't know. A couple little tweaks, but we're pretty much there. And all I have left to do is hook up the kill switch on the motor. I'm going to forego the relay on the, you know, the second safety. Maybe I'll put that in later, but I kind of want a solid state. All right, so in the function setup, in the endpoints, I went ahead and set my channel 1, which is this one here for the turning. They set it all the way down to 20%. And you can modify it just by setting that there, and then you can use the right stick over to move it into the next mode. And so 20% makes it a lot less reactive. So now if we go here, try to get both in the same shot, it's not as, like I can go farther. It can still act violently. It can still do it, but it's not as touchy as it was. I might move it even down from 20% a little bit more. But that's pretty good. And I think I might also be able to take off the acceleration when I first, you know, I'm in the garage, I'm not going to do it, but the acceleration when it first takes off can kind of pop a little bit of a wheelie. And I think I can set an acceleration mode in here too. All right, so the majority of everything is working. Haven't done an engine live test yet. I'm going to wrap this video up now. I think that this covers all the electronics in enough detail. And this one's getting kind of long. So in the next part, we will do a live test, and I'll go buy a bunch of bags of ice or something.